the title of the talk was Using History as Education, Inquiring About Inquiry. And so this is kind of where I want to make that point, that history of science is actually, the students are inquiring about the scientific inquiry process. The historical stories are the data that students use. If you think about inductive reasoning, the story provides the data, and then they wrestle with what's going on in the story and try and through my teaching and my interaction with students, I help them get to the ideas that describe science, the nature of science. So just like I have my students collect mass and volume and floating and sinking data, and then we talk about how mass affects floating and how volume affects floating, and then we kind of get them to the mass divided by volume equals density equation. I can use the historical episodes to help them ask the right questions to get to the nature of science ideas. And of course, I've been kind of telling you this all along, that you have to connect the historical examples to stuff that they've already done, whether it's the magistrate that they've seen, or the black box activity that they've done, or the inquiry lab that they did, or you can connect it to the cookbook lab they've done. How is what this scientist is doing different from what you did? And hopefully one of the things that the students says is, well, this scientist didn't have a step-by-step procedure that they were following. And then there's 3 different levels. This is a professor of mine, Clough 2006. He talks about how we need to constantly go back and forth between these 3 different levels. And we've kind of already talked about that. I kind of just said this actually. That historical examples, we need to have students connect them back to their inquiry, and these 2 we connect them back to the black box, because the reason the black box are so important is because the kids don't have to think about science. Science is difficult. Like thinking about what density means, and then also thinking about how they tried to figure out density is difficult. Thinking about why they didn't use a supernatural explanation for the popsicle stick, they can focus on the supernatural explanation part, because a popsicle stick isn't hard to understand. And so going back and forth between all 3 of these, a lot of people do this once, and then they try and spend the rest of the year doing this, and they leave this out. My suggestion is to do this, this, and this every single unit. Because then, and actually what I try and do is I try and tailor my black box activities to the historical examples that we're going to be talking about, and then the inquiry investigations fit because it's the same content. And one example that I have is I have something that I call the Rutherford tray. I don't tell the kids about the Rutherford tray, but they roll a marble underneath a covered up space, and so that's like the alpha particle going in and hitting the side of, and they have to figure out what the shape is underneath. Kind of like Rutherford shooting alpha particles. It's not exactly the same, obviously, but they can make those connections to the content as well as to the nature of science. History and inquiry are not enough. We don't. If I have students collect mass and volume and floating data on a bunch of objects, I don't expect them to all of a sudden come up with D equals M over V. Like that's just not going to happen. Discovery teaching is a myth. Kids don't just discover the laws of nature that took human beings thousands of years to come up with. And so what we need to do is we, as teachers, have an important role to play. And so this is, actually, people have actually studied this. Those guys have made careers for themselves out of this. That if you have kids do inquiry, if you have kids read about the history, they're not going to come to the nature of science. You have to actually engage them in that conversation.